The sky over Shenzhen Bay was quiet. A massive steel structure hung suspended in the air. It was a bridge without a beginning or an end. It was slowly, almost silently, rising between two new skyscrapers. This was the culmination of months of planning and years of construction. The bridge, weighing an incredible 6,000 tons, was nearing its final destination. It had to reach a height of 119.15 meters. That is the equivalent of a 40-story building. On the ground, hundreds of engineers, technicians, and workers watched. Their eyes were fixed on the colossal steel giant. They were a sea of yellow hard hats, all looking up. Every person held their breath, united in a single silent hope. This massive structure is the sky bridge for Tower C, a new landmark in the Shenzhen Bay Super Headquarters base. It connects the two towers of the complex, creating a horizontal skyscraper high above the ground. The bridge itself is a multi-level space. It will house art galleries, cafes, observation decks. It is designed to be a public space in the sky. This single operation was the most complex and riskiest part of the entire construction project. Most sky bridges are built in sections, piece by piece, high in the air. This method of building the entire bridge on the ground and lifting it in one go is faster and safer in many ways. However, the lift itself becomes a moment of extreme risk. The success of this single event was a benchmark for the industry. This story is about how they did it. It's a look inside the science and the strategy behind this incredible feat of heavy lifting. The project at the heart of this story is called Tower C. It is not a single building, but a pair of skyscrapers. One tower will reach nearly 400 meters, a true super tall. Its sibling is slightly shorter but equally impressive. The towers twist. Their facades are a complex pattern of glass and steel. These are not just offices. They are a vertical city. Inside, high-tech office spaces, entertainment venues, vast public areas. At the base, they stand apart. As they rise, they reach toward each other. That gesture sets the stage for the sky bridge. The towers were engineered with that connection in mind. At the connection level, their primary structures were reinforced. Massive steel brackets protrude like arms, ready to receive the bridge. The structure at the center of our story is more than a simple bridge. It is a building in its own right, a horizontal skyscraper suspended in the air. 90 meters long, 52 meters wide, 30 meters high. The total weight, including floors and fittings, is approximately 6,000 metric tons. That had to be lifted in a single, continuous operation. Designed by Zaha Hadid architects. Their signature fluid, organic style is obvious. The steelwork curves and flows, echoing the twisting towers. That complex shape made the engineering even harder. This structure was asymmetrical, weight not evenly distributed. Calculating the precise center of gravity was critical. An operation of this magnitude is not the work of one company. It requires a symphony of specialists, a coalition of experts from around the world. The architectural design came from Zaha Hadid Architects. The primary contractor was China Construction Third Engineering Bureau. A specialized team was needed for the lift itself. Structural engineering consultants from Bureau Happold worked alongside the architects. The technology provider supplied the hydraulic strandjack system. Their technicians were on site to operate and monitor the equipment throughout the lift. This collaboration was essential. They had to work in perfect alignment. Communication was constant. Every detail was shared, checked, and double-checked. The project brought together decades of experience. This collective intelligence made the impossible seem possible. The team was as strong and as interconnected as the steel structure they were about to raise. Long before any steel was moved, the entire lift was performed hundreds of times. Inside powerful computers, engineers created a highly detailed digital twin of the entire site. Every steel beam, every cable, every hydraulic jack. The team tested every variable. What if the load shifted slightly? What if a sudden gust of wind hit from the east? They watched stress flow through the bridge and towers. The virtual plan became the definitive script for the real event. By lift day, The process felt familiar. They were executing a plan that had already been proven successful in the digital realm. One of the biggest unknowns in any major lift is the weather. For the Tower C Skybridge lift, wind was the single greatest external threat. A 6,000-ton steel structure presents a massive surface area. Suspended high, it can act like a giant sail. The planning phase included a detailed meteorological study. They discovered early morning, just after dawn, typically offered a calm window. Days before the lift, real-time monitoring became critical. Anemometers were placed at different tower heights. That data fed directly into the lift control system. The team set strict weather criteria. If wind exceeded about 10 meters per second, the lift would be paused. At its core, the lift was an exercise in simple, powerful physics. The solution was a system of hydraulic strand jacks. A strand jack is essentially a hollow hydraulic cylinder. It is a slow, powerful, and incredibly precise way of climbing a rope of steel. For this project, 8 of these massive strand jacks were used. 4 jacks were placed on each tower. Engineers had spent months calculating the bridge's exact center of gravity. The lifting points had to be positioned perfectly around this center. The entire system was controlled by a single computer. It ensured that each one pulled with exactly the same force and at exactly the same speed. This closed-loop control system was the brain of the operation. The most important part of planning for success is planning for failure. The engineering team spent countless hours imagining what could go wrong. What if one of the hydraulic strand jacks failed mid-lift? The remaining 7 jacks had enough capacity to safely hold the entire load. What if the main power supply was cut off? The entire lifting system was connected to a series of massive backup generators. On the day of the lift, when a minor alarm sounded, the team did not panic. They calmly consulted their checklist, identified the issue, and switched to a backup sensor. The lift continued. An exclusion zone was established around the entire lift area. On the ground, rescue teams were on standby. This philosophy of preparing for the worst created a deep sense of confidence within the team. They were not hoping for the best, they were prepared for the worst. The day of the big lift began in darkness. Long before the sun rose over Shenzhen Bay, the site was a hive of activity. Final checks had been going on all night, inspecting every connection, inspecting every cable, inspecting every sensor one last time.
All stations, final weather is go. Commence lift. The project director gave the go-ahead over the radio. The command, commence lift.
With a groan of steel, the 6,000-ton bridge began to separate from its supports. It was airborne. The lift was paused, the first major hold point. Surveyors used laser instruments to confirm perfect level. The breakout was successful. The path to the sky was now open. The main ascent began quietly and deliberately, a steady 12 meters per hour. Inside the control room, the atmosphere was one of intense concentration. The human team was watching its every move, acting as a vigilant overseer. It passed the 30-meter mark, then 50, then 70. With every meter gained, the risk profile changed. During these pauses, the bridge hung motionless, a strange and breathtaking sight against the blue sky. As the skybridge ascended past the 100-meter mark, it was approaching the massive steel brackets, the docking ports. The clearance between the bridge and the towers was tight. Guiding the 6,000-ton structure into this narrow slot required the utmost precision.
Move east 2 centimeters. Hold. It was like threading a giant needle 100 meters in the air. Every command was executed with slow, deliberate force.
Finally, the bridge reached its target elevation of 119.15 meters. It was not yet secured, but it was home. The initial connection involved a system of massive steel pins. This action created the first physical, structural connection. Very slowly, the hydraulic pressure in the strand jacks was gradually released, allowing its full weight to settle onto the permanent supports. Now, an army of specialist welders began the monumental task of permanently fusing the bridge to the towers, turning 3 separate structures into a single, monolithic entity. Before a single member of the public could set foot on it, the bridge had to prove it was safe. Huge water bladders were brought onto the bridge and slowly filled, incrementally increasing the weight. At each stage of loading, an array of sensors measured the bridge's reaction. Every piece of data was compared against the digital twin model. The journey from a 6,000-ton block of steel on the ground to a fully tested, certified horizontal skyscraper was complete. The successful lift of the Tower C Sky Bridge was more than just another step. It was a landmark event in the history of engineering. It was the unseen hours of calculation and contingency planning that made the final act possible. All pointing to one truth: success is born from preparation. Today, the Sky Bridge is part of the Shenzhen skyline. It will be a public space unlike any other. A horizontal street in the clouds. Born of immense force and delicate control, the bridge stands as a symbol of Shenzhen's drive to the future. A connection made of steel. A connection between ground and sky. A connection between the city and its aspirations.